So today we're going to go over impulse. Okay. So what you want to do is make sure you copy these 3 examples down. So I'm going to go over the first one. Now the first one, this is asking for momentum. Okay. So the formula for momentum we learned is P equals mv. And those are the units, kilograms and meters per second. So if we take a look at the problem here, they're giving us 500 kilograms and 3 meters per second. So 500, 3 meters per second, we multiply the 3. And there's our answer. Really quick, simple, fast, easy to do. Okay. Now I'm going to have to erase this so that I can go over the next formula. And if we look at the second problem, it says what is the impulse or the change in momentum of a 750 kilogram race car slowed from 32 meters per second to 15 meters per second? What is its change in momentum? So in this formula, we are going to use we're going to call this change in momentum. And you know what? Change in momentum equals so this is the formula. Mass times velocity final. And your mass is always in kilograms. And your velocity is meters per second, right? So if we take a look at that example, they're giving us a mass, 750, which we're going to plug in to both. Masses. And our initial, the first velocity they give us is 32 and 15. So initial is 32. And the other one is 15, okay? So now we're going to multiply 750 times 15. Gives me 11,250. $750 times 32, 24,000. And then I'm going to subtract the two numbers. Minus 11,250. And that gives me 12,750. Okay. And this is kilograms times meters per second. That's our change in momentum. Okay, pretty straightforward. Okay, and our last formula that we're going to use is the next example. A truck hits a brick wall with a force of 120 newtons. The collision takes 1.3 seconds. What's the impulse? So the third formula is impulse equals force times the change in time. And the force here is 120 and 1.3 seconds. Forces in newtons and seconds. And the force we said was 120 and 1.3. So we're just going to multiply those two numbers. 120 times 1.3. And that gives me 156. Okay, and since we're multiplying newtons and seconds, or units or newtons times seconds, 156. Okay, so now what we're going to learn is that if you notice, the change in momentum, mass times velocity, is actually this one, right? It's the same. Essentially, you can just subtract the velocities, but it's a little bit easier to see it this way. It might be just one extra little step of work, but I prefer it this way because it makes so much more sense with this next problem that we're going to be doing. Okay, so let me go ahead and erase this and let me show you, because there's going to be a fourth formula where we kind of mix everything up. And this fourth formula is anytime that they give you a mass or a velocity and it's asking for a change in momentum, you're going to use this formula. Okay? If they just give you mass and velocity and they ask for momentum just by itself, it's this formula. This formula is pretty much this formula, but if it asks for the change in something, you are subtracting from an initial and a final. Impulse is supposed to be this, newtons and seconds. So if they give you newtons and seconds, you use this formula. If they give you mass and velocity, you use either this formula or this formula. But what if they give you everything? They give you force, time, and mass, and a velocity. So what you're going to do in this case is the impulse and the change in momentum, you are going to set them equal to each other. Okay, so this is the fourth formula, which is force times time equals the change in momentum. Okay, and that's what we're going to be working with today. It's this. Let me show you what I mean. So what I suggest that you do is those formulas, these formulas, is maybe just copy them on the right side on a new section. Well, this one especially, since it's kind of like a new formula. And what you want to do is these problems should be 5, and then this should be problem number 6. What I would suggest that you do, like I said, is go ahead and copy these and write them down in a new section. Okay. Actually, you know what? There you go. There we go. This is problem number 5. Okay, and there is another problem as well. This is 2 examples, and here's the last example that you want to copy down, and I'm going to show you how to answer these 3. Okay, so if we look at the first one, it says find the change in momentum of a baseball, and they give you the mass, and it's traveling at 17 meters per second. After you hit it with a bat, it travels 26 meters per second. If the ball took 0.03 seconds of contact, find the force. I mean, when you look at these problems, it's like, oh my gosh, that's a lot of information. They're giving you all sorts of stuff. How are we supposed to work these problems out? Well, this is where these formulas come in, okay? This is where this becomes very, very handy. So let me go ahead and erase all of this here. And I'm going to write that formula up here. Force times time equals mvf minus mvi. So this is question number 4. Okay. So now all you have to do is plug in what they give you, okay? So, okay, they give us a mass, 0.145, so let's plug that in, the mass, 0.145, 0.145, right? Times, well, it's times and times. Okay, so we plug those numbers in. Let's see the other numbers that they give us. They give us an initial and a final. The initial is 17 and 26. Initial is 17 and 26 is the final, right? Okay. Let's look at, they're giving us a time, 0.03 seconds. The time is 0.03 seconds, and there we go. We are solving for force, right? So this problem, it looks easy now, right? Do what it's telling you to do. So here it's telling me to do 0.0145 times 26, and that gives me 0.377. 0.377. 0.0145 times 17 gives me 0.2465. Now I'm going to subtract those two numbers, 0.377 minus 0.2465, and that gives me 0.1305. So how do you solve for force? By dividing. That cancels, and now we're left with 0.1305 divided by 0.03, and that gives me 4.35. Since this is a force, it's newtons. So remember, anytime that you have a collision, that collision, it's going to briefly touch, and while that briefly touches for less than a second, here it's less than a second, 0.03 seconds, we know the exact force that was exerted on that object. Okay, so let's try doing another example. I'm going to erase this here. And we're going to jump to question number 5. And it's done the same way, guys. So find the change in velocity when a force of 300 newtons is applied for 0.03 seconds to a 2-kilogram rock. Notice they're giving us, if they give us just force and newtons, force and time, you would just multiply those two. If they give you this and a velocity, then you would use a momentum, but they're giving you everything. So you're going to use that formula that sets everything up. So let's plug in what we know. 300.03. The force is 300. Time is 0.03. And this is actually mass. This is actually mass times the change in velocity. Okay? So since they just gives us a mass of 2, we're just solving for the velocity in general, okay, in total. So we can just set it up like this, okay? So all we do is 300 times 0.03, 300 times 0.03, that gives me 9, equals 2v, divide both sides by 2, 9 divided by 2 is 4.5. 4.5 meters per second. It should be 4.5, okay? So notice this one was way faster to solve than the other ones, right? And yeah, let's keep this party going. Let's do the next example, example number 6. All right, so find the force of a 30 kilogram object that is pushed from 5 meters per second to 12 in 9 seconds. So they're giving us 30 kilograms. All right, let's plug that in. 30 kilograms. Right? And they are giving us initial 5 and 12 is final. 5 is initial, 12 is final. 5 is initial, 12 is final. And here we are multiplying these two. And what else do they give us? They give us a time, 9 seconds. Time, 9 seconds. And we're going to solve for force. So we have everything laid out. Do what it tells you. So F9 equals 30 times 12. Let's start there. 30 times 12. 30 times 12 gives me 360. 30 times 5, 150. 360 minus 150, 210. F9 equals 210. So to solve for F, we divide by 9. Okay, but we're doing that. F stays, right? So F is going to equal 210 divided by 9. And that gives me 23. We'll just say 23. 23 newtons. Okay. And there we go. Simple, right? We have our formulas that are set to each other. And we can find the force, the time, the mass, the velocity. We can find all that stuff in that quick little impact. And it's any impact that happens. Any and every impact that happens in the universe, it pretty much follows this formula, and we can figure out force, time, mass, and velocity.